On to question 9. This is again, give me a sec. November 25, paper 1, BTHL. And some of these questions do apply to SL as well. They're in the SL paper, so definitely stay on and you'll learn a lot. Okay, so we have question 9. Shows a drawing of the components of a typical machine that's removed. What type of graphical model is shown in figure 4? Now, so what I'll be doing with all of these questions, as I've done previously, is just explain every point and possibility and understand which one is our correct answer and which ones are not and why. So definitely go check out the playlist and I'll just continue. So we don't have the image, but we can sort of guess what type of graphical model is shown in figure 4. Now, they say it's a drawing of the components of a typical machine, so immediately I'm thinking probably not orthographic. It's a bit too small. 2D sketch, no, you can't see all the components. It's most likely an assembly drawing, right? That's where we have all our components sitting together and it shows how these components, let's say, fit together. Let's say we have a tray and then we have box, right? And so how does this fit together is essentially an assembly drawing. And so that's how we see all the components. So let's define each of these. Assembly drawing, we can say, is a diagram that shows how these components, right, fit together to fit together to make a whole, as a whole, right, as a whole product, and that's usually given in a exploded isometric form. So it wouldn't be orthographic, it wouldn't be 2D, and it could be a 2-point perspective, but that is more for a realistic drawing rather than a assembly drawing. Exploded isometric, right? And I have some music in the background, hopefully it's not too distracting. Okay, then we have, let's go from the start, orthographic projection. And these are essentially uh 2D views, right? 2D views to help, let's say, detailed dimension, right? We have usually something like this, and then we have this, and we have this, right? And this is our maybe top plan view. We have our front, and we have our side, right? And we can say right or left. And so 2D views, detailed dimension, to support manufacture, right? Or uh, and accurate. They have to be accurate dimensions and to scale, right? To scale. And you have to always give the scale somewhere here, right? You always say 1, 2, 3, and you have that logo. Uh, right? So definitely go check that out. Give it a search. The logo for symbol for orthographic, to support or guide production, especially when you're outsourcing to some manufacturer, especially outsourcing because they need a reference, right? They need your CAD models, they need your dimensions, exact dimensions that you want, and this gives them a quick reference and they can check anything. Outsourcing to outsourcing manufacturer. Okay, next 2D sketch, exact same thing, but this would be less of a that's less detailed, right? It's just a 2D view uh to maybe brainstorm, uh freehand sketching maybe, freehand sketching, freehand drawing, right? Just to uh inspire ideas, uh get feedback, uh recognize, or visualize conceptual models that we have in our brain or that we want to put into a visible form. Conceptual model, uh, right? And so that's mainly that 2 point perspective is something like this. Let's say we have 2 points and we have a box. What we want to do is make sure these align. So we have these points converging, right? And then what we'd have is all these sides converge to these 2 points. And this side would converge to this point. Yep. We can even have a 3 point, but we would have to make this sort of like this, right? 3 point. So this gives us more realistic view, uh, as if it was uh, viewed by a person, right? When we see things, we are seeing things from an angle. We're not seeing them exactly with an isometric point of view. There's a bending of light, let's say. Okay, now we can move on to, in fact, the important thing to say is drawn uh, such that the object or drawn to depict object getting smaller uh, and closer together as they're further apart, as they the further they are from our view, uh, further from our view, right? Hopefully that makes sense. Now on to question 10. What is described as the ability to simulate a real situation and interact with a near natural, interact with it in a near natural way? So that would be probably, I would say virtual reality, right? That is where we are simulating, virtually simulating, actually simulate reality, right? A real situation, and then we're interacting with it, right? We can move our hand around our joystick and it interacts with this virtual field. And this is in fact the exact definition for virtual reality. So in fact, no need to define it. Let me just highlight this. The ability to simulate a real situation and interact with it in a near natural way. That is what virtual reality is. That's our definition in our glossary of terms. Then we can go into digital twin, digital human, sorry. That is just a, simulation of a person. It's a virtual copy, right? Virtual or computer simulation or copy of a person, of a human body, right? It has the exact shape, size, you know, uh, muscle. We can test different things like muscle, uh, mass, muscle flex. We say maybe stretch, reach. So we can test a lot of different things. Weight, right? So pretend we're in a car. We don't want to use a real human. We want to use a digital human to test what would happen to a person of maybe 6'5". Uh, they have broad shoulders. They have 5 meter reach. Sorry, 1.5 meter reach. They have 75 kgs, something like that. And so what we can say is it simulates the mechanical. These are mechanical and physical, uh, bio biological, right? Muscle is biological aspects of humans. So it's literally a copy of a human. And so simulation just means, let's say, using a model to analyze or test or represent a real world situation, right? But it doesn't allow us to interact with it in a almost natural way. Virtual reality is a specific type of simulation that allows us to do so. And then now we have finite element analysis. That is where we, break, or let's say we have an object in CAD like this. Our CAD software breaks everything into tiny, finite elements, right? Little particles. So these are called. It breaks it down into a mesh, breaks a model into a mesh, which means thousands of small finite elements, which is like consider like atoms or just small pieces of the model. And then it looks at how those small pieces interact with each other when you add a weight, when you test injection molding, for example. And so this is all throughout, right? These are finite elements. And let's give it a definition. This helps us calculate specifics, right? It's accurate. Calculate. And it's a simulation in itself. So calculate and simulate unknown factors. And so that's why simulation here is completely the wrong answer, because all of these are simulations. So it's not very specific, and this is a very specific definition that's being asked. So calculate and simulate unknown factors or forces, right? Let's say we're giving it a push, we want to test that in FEA. We don't want to build a new prototype every time, uh, especially when we have expensive products. So in products, unknown factors or forces in products using CAD software like Fusion 360. And so and what we can say is maybe some of you have seen that airplane question. So simulating stresses or maybe elasticity, or we can say strain, pressure, deformation. That's one thing you can look at when you do injection molding analysis. Uh, right, and you can say of a plane, wings, uh, car, uh, frame, right? So all these different things, and this is how you apply it in a paper two question. So next, I'll move on to question 11. Which type of model is normally explored at the start of any designing process? Uh, this is our conceptual model, right? Right, like I mentioned earlier. How about we do this in a different color, right? A model that it's what we come up with in our mind when we come up with an idea, right? It's a model that exists in our mind. It's a concept. It hasn't been put into maybe a graphical form. It hasn't been put into a physical form like a prototype. It hasn't been sketched, right? Graphical is like sketch, physical, virtual is CAD, physical is prototype, physical prototype like card or 3D print, right? So a model that exists in our minds, or let's just say in mind, anyone's mind, that helps us know, right? Know our ideas, understand them, know, understand, and develop ideas, initial ideas. Okay, but you can't further develop it without, using a sketch, using physical modeling, and so that's where those come in. And so I'll just give each of these a definition. If you guys already know this, definitely skip on to the next few questions. I'm just going through every single thing to give you guys a pre-exam, you know, support, visualization of an idea, and that is usually on paper or software. So graphical means you can have or virtually on software. So and that can be 2D, 3D. We can have ISO, uh, perspective, ortho, right? Uh, and when we say software, we can even have flow charts, diagrams, uh, mind maps, which is sort of what we're doing here, right? Mind maps. And so just how we get our ideas out and sort of develop them initially. Then we have our physical model that helps us test or visualize concretely in the real world with something that we can touch, tangible. It has to be tangible. And so that's exactly the kind of definition we want to give. So let me this. I'm going to say is a and the physical models can be scaled, right, up or down. So smaller or larger, uh, tangible versions of a product of product or object that a user or designer or someone can interact with physically. Or let's just shorten this and say physically interact of a product that can be physically interacted with. Can be. The user can be physically interacted with. Okay, that's some bad English, but hopefully you guys understand. And then we have a virtual model that is our CAD based, like we said here, CAD based interactive models, right? When we use Fusion 360, we can move stuff around, we can change everything, we can test it using FEA, we can do all sorts of testing, so that's interactive. And it uses surface modeling, so it's either surface or you can do solid modeling where you do the internal components as well. You're not just doing the outer look, right? Surface plus solid modeling. That is what virtual prototyping is. And so we can move on to question 12. Let's see, is this topic 3? This is topic 4, so we'll move on to that later. Hopefully this helped, guys. This is topic 3. We only did 3 questions, but I think I went through it quite thoroughly. Do let me know if you have any feedback. Otherwise, do drop a like and subscribe. Have a great week.